Hi to everyone, this is Gokilapriya, Assistant Professor, Department of Computer Science, KSR College of Arts and Science for Women, Tiruchengood. Today I am going to discuss about C++ programming. The first topic is destructors in C++. Definition: special member function that cleans up resources when an object is destroyed. For we are using syntax for this class name as a syntax automatically called when objects goes out of scope or is explicitly deleted. Destructors is used for freeing, dynamically allocating memory, closing files, releasing system resources. For example, here we are using class name as a my class, open parenthesis, public my class, then clean up code here. Here we are using destructors in this example. Next one is operator overloading. Allows custom implementation of operators for user defined types. It enhances code readability and inductive usage of classes. Common overload operators plus, minus, multiplication, division, equal, double equal, greater than, less than. For we are using syntax as return type, operator, symbol, parameters. For example, class, here we have to use class as a complex, then open branches, public, complex operator plus constant, complex and other. Addition logic here, closing parenthesis. Next one is type conversions. Implicit conversion, automatic type conversion by the compiler. Explicit conversion, programmer defined conversion using casting. Next one is user defined conversions. Conversion constructor, here we are using single argument constructor. Conversion operator allows conversion to other types. For example, here we are using class as a fraction, then open parenthesis, public fraction into number, numerator of number, comma, denominator of 1, open closing parenthesis. Then here we are using operator as a double, then constant, open parenthesis, return, double, numerator, denominator, closing parenthesis. Private, here we are using int numerator and denominator. Next one is inheritance basics. The mechanism to create new classes based on existing classes. Promotes code reuse and establishes a hierarchical relationship. The syntax we are using for inheritance: class, derived class, colon, access specifier, base class. Types of inheritance. There are 3 types of inheritance in C++. Single inheritance, multiple inheritance, multi-level inheritance. For example, class, animal, base class members. Next one is class, dog, public animal, then derived class member. Here class animal is a base class members, then the class dog is a derived class members. Next one is extending classes. Adding new functionality to derived classes. That means already we are having class, we have to adding one more functionality in that class is called derived class. Overriding base class methods. Using override keyword for explicit method overriding. Protected members accessible in derived classes but not outside. For example, class shape, open parenthesis, public, virtual double area, constant equal to 0, closing parenthesis, colon, semicolon. Class circle, public shape, open parenthesis, public double area, open closing parenthesis, constant override, circle area calculation. Here class shape we have to declare, then we have to derive one more function, virtual double area, then we have to use class circle. Here we have class shape we have declared. Then we have to declared another one area, class circle. So we have using extending classes. These are the example of extending classes. Pointers in OOPS. It store memory addresses of objects. Allow dynamic memory allocation and polymorphism. Syntax for pointers. Class name int, pointer name equal to new class name. Important operations. Dereferencing. Accessing object members using operator. Deleting, freeing, dynamically allocating memory. For example, shape into shape pointer equal to new circle of 5. Double area equal to shape pointer arrow mark area of delete shape pointer. Here we have to free up the memory space of pointer. Next one is virtual functions. It enable runtime polymorphism declared using virtual keyword in base class, overwritten in derived class. Late binding. Correct function called based on actual object type. For example, syntax of virtual functions: class base open parenthesis public virtual void function base implementation. Here we have to use class as a base, then we have to declare the virtual function void function. Pure virtual functions and abstract classes. Pure virtual function with no implementation. Syntax: virtual return type function name open closing equal to 0. Abstract class. Class with at least one pure virtual function cannot instantiate abstract classes directly. Derived class must implement all pure virtual functions. For example, class we have to using abstract base, then open branches public virtual void pure virtual function. Here we have to using a pure virtual function syntax and abstract classes. Next one is polymorphism. In C++, ability of object to take on multiple forms, types, combined term polymorphism, function overloading, operator overloading. Then runtime polymorphism have two types. The first one is virtual functions, second one is function overriding benefits, code flexibility and reusability, extensibility of programs. For example, void process shape into shape, cout, we have to declare the area shape to area. Here we have to use the polymorphism through void process shape function. Thank you.